Hello, so in this lesson I'm come to continue with where we left off last week, or the last lesson. That was lesson 3 for the student. In lesson 3 I treated assigning values to your variables, and we dealt with string values, that's string data, and we dealt with integers. These were the two main things, and we used the string. We used a simple 3 LEDs to, and we assigned each pin to a variable, and we saw the importance of variables in that scenario. We also assigned a string that was turning off the lights. Light is on, light is off, buzzer is on, and a couple of things in there. And I said we're going to do float, but we'll do float in the next lesson. So in this lesson, we're going to look at arithmetic. Basically addition, subtraction, multiplication. This the basic operations that we know. What we're going to do as well is we're also going to talk about floats, and I'm going to use the arithmetic to also explain floats a bit. So let's get in. When doing this lesson, I had some challenges with I'll write a code and expect to see the results on the serial monitor. It wasn't happening. So then I decided to print a normal string in it first, and then it worked. I don't really know what happened there, but let's go on. So we are going to do simple additions, just like a calculator. To do that, we are going to start with a variable. Now what I'm doing here, you remember previously we learned to assign a value to a variable. This time we are just declaring the variable. We are not assigning any value. So to do that, you just say int a, float a, this, whatever the variable is, you put the data type and then the variable there and semicolon. This means that the variable is currently empty, but you have declared it. So there is a variable for that. So then we're going to do serial.begin, since we're going to work with our serial monitor. And if you see, I've opened the serial monitor here because everything we're going to do is basically going to be the serial monitor, and my Arduino is connected. So then I've said that a is equal to what? So now we're going to do addition, okay? Just to make sure that if there is a problem with the serial monitor, I can tell. I'm going to write serial.println. You get me? This is just a check, just so that if it doesn't print, I know whether it's from the serial monitor or it's not from the serial monitor. By once it prints the hello world, I know that okay, the serial monitor is working. What just happened? So that's the check, because I'm doing this because due to some weird reasons it wasn't working before. So I have 2 plus 2. So this is just addition. So kindly note, this is really not part. Okay, this is just a check that I am doing, but this is really not part. We are dealing with arithmetics. So this is what we are doing, because we've declared over here that there's a variable called a. Now we are saying that 2 plus 2 should be assigned to a. So now if we say print a, now you realize that we are doing everything in the void setup. This is because we don't want the code to be like running. We just want it to display one thing. Let me change it to 2 plus 6. So serial dot print line then a. So what should happen here is that it should print a should be the result of 2 plus 6, right, which is 8. So if we upload, we should see hello world appear here and 8, because then the first thing we want to print is hello world, the second thing we want to print is the result of 2 plus 6. So this is simple arithmetic, right? So we've done that. We can do something like 6 minus 5, right? Let's try that. 6 minus 5. 1. So we've done addition, subtraction. So So let's do multiplication. Multiplication is you're going to use a star. 6 times 4. Then let's do division. Division 6 times 2, which will give us 3. So you teach the students that okay, you can use for any programming language, you can use it as a calculator as well. So we're gonna skip things like modulus and things like that. Just the simple plus, minus, multiplication, and the simple operations that we know. Okay, so now this is interesting. Let's do something else. So now we've printed 6 blah blah blah. This is 3. 6 divided by 2 is 3. Another thing we can do is that now a is, we can say let a be now equal to a plus, do you get what I'm doing here? So we know that a is 3 now because 6 divided by 2 is 3. So now we can say a should be equal to a, which is 3, plus, let's say, 12. You get me? So what the computer is going to do is that it's going to first take care of this arithmetic using this variable, and then if we decide to now print a again, it's going to print this a over here. You get me? It will first compute what's on the right, then it will assign it to what's on the left. Kindly note that this equal to, or remember to emphasize, this equal to is not equal to. It's actually not equal to, it is assigning. So it's doing this computation, then it's assigning. Equal to over here means what? Assign. Then it's assigning this to a variable called a, which we declared over here. But it's no longer this a, because this a was 3, but this a is now this a plus 12. So let me just show you. Print a. Did I make a mistake here? Yes, I did. So let's run this and you see what will, oh sorry, I made a mistake. Let's run this and you see what will happen. So we have hello world, we have 3, and we have 15. So this 15 is actually a result of what? The 3 which came out of this a plus 12. So getting me? Yeah. So here you are introducing the student to how to use his Arduino IDE to compute values, and then that was to compute simple arithmetic calculations, and then how to use the same variable, the result of the same variable, to compute another value with the same thing. You get it? Okay. So that's that. Now we'll take it a step further. Let's introduce another variable called b. You can see where we are going with this. So over here, we introduce another variable called b, which we've declared, and here we can say b is equal to, let's say, 5 times 6, right? So we'll start by printing both a and b. So print line b. Now that we've done this, we expect the results of this to be printed here, right? Okay, so let's just do that. So what we should have is the result of a, what a is based on this arithmetic, based on this, what b is based on this, before we have this, right? So what we'll do is here to, let's say b is equal to b again plus, let's do minus, let's do 6. You get it? Okay. Now after we've computed that, it will not just show, we need to see out the print line, sorry, there's something on my screen. Dot print line b. So we'll get first we'll get values for a and b based on this computation. Then we'll get values for a and b based on the second computation. Hope you see what is happening here. So we should see hello world. The first one, 6 divided by 2. You see answer is 3. Then 5 times 6, which is b, which is 30. Then we are saying that a is equal to the first value of a, or a is equal to the first value of a plus 12, which is actually not equal to, but value is being assigned. So we have 12. Then the second one we have 24 because this was 30. So 30 minus 6 will give us 24. So we've done that. Now we can take it a step further and work with a and b together. So let's introduce a new variable called c. Remember that you can't just come and write c is equal to blah 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 blah. It won't work. You first need to declare c. So we are now using our variables in different ways. You first need to declare c as a global variable, and then you can say c is equal to, let's say, a plus b. This should be fun. A plus b. Then you come in and say serial dot print line. So over here, we are just teaching him how to, as I said, how to do simple arithmetic, but we are playing around with the numbers and with the variables so that he gets used to the possibilities and what you can do with it. So what should happen is that the last result of a and b, it should sum up here and you should print it as c. So let's do that. And voila, we have 39 because a is 15 and b is 24. So if you add them together, you should have 39. Let's see. So that's it. We are computing. Now you realize that everything we've done has been like whole numbers. There's no complications, no decimals and stuff like that. Okay, so what if we needed to use decimals? Now, usually in Arduino, we try to avoid decimals as much as possible. That's why we use int, because then whatever it is with int, it will round it up to the nearest whole number. Yeah, it will round it up to the nearest whole number. So, but then we need to also learn about floats. So floats is basically decimal numbers. That's basically all. So let's change. We are going to change these to floats. So we're going to change these to floats. Now watch what is going to happen. We change these to floats. You see what's happening? It's no longer saying 330. Now it's saying 3.00, 30.00, 15.00, because it's giving us 2 decimal places. It's rounding up to 2 decimal places. Now let's play around with like the division so that we can actually get some decimal places. You get it? So it's always going to round up to 2 decimal places. Let's make this. Let's make this 1. Let's make this 2.3. Okay, I think that should work. What am I doing? So B. Okay, so let's try this. Let's play around with these figures. We've changed some things. So over here we should have some decimal. So here you can see the first one is half. It says it's approximated it actually. So 1 over 2, 0.5, it's approximated 0.5 to 0. This is because I realized that Arduino generally tries to avoid like decimals as much as possible. So over here you see 11.5. 0.8 is 0 is 1 over 2, saying is 0.00. 11.5, that's, yeah. So usually it can do 0.5, but let's do something. 0.5, let's make it times 1. But I realize generally tries to avoid decimals. But if I do 0.5, it will, and it should print 0. You get me? But when when you divide, what it does is that it just tries to round up to the nearest whole number. So you see we are getting some decimals here. Now if we should change the floats, watch this, to integers, there's going to be a problem. Let's see what's going to happen if you change to integers. You see what's going to happen. You see what's going to happen. See what's going to happen. Both. You see? So everything has changed like whole numbers. It's rounded everything up for you. So that's what you have. That's what you have. That's it. There's a way to specify the nearest the decimal places in all of this. Not sure that will be part of his lessons. So that's it for floats and for simple arithmetic. Thank you. This was a short one.